Today we're going to talk about Earth's layers, and then after that we'll go into relative dating. Alright, so there are three compositional layers when we're talking about layers of the Earth. Okay? And composition layers are things that are going to be identified by chemical composition. That's the makeup of these layers, like what makes them up, what items. Okay, there are three. 1, 2, and 3. The crust, the mantle, and the core. When we're talking about the crust, we are talking about two types. Okay, type 1 is continental. That's going to be any type of crust that's going to be made up of continent. So it's solid. Okay, solid. Type 2 is oceanic. That's going to be any crust that's made up of ocean. And so it's going to be water on top with thin land underneath. Okay? Now, you need to understand that both types contain oxygen, silicon, and aluminum. And the oceanic crust is denser and contains more iron, calcium, and magnesium. Okay? Both of them, though, have land on the base because we know that if you go in the ocean, what's underneath your feet? Sand. That's considered the continental land. That's still continental crust, okay? All right, type 2 is the mantle. And the mantle is this orange piece right here. And within the mantle, there is hot, slow, flowing rock. Convection currents happen where the hot rock rises and the cool rock sinks. So we know one goes up and one goes down. And then the denser, this layer is denser than the crust, okay? It's also a lot thicker than the crust. And the third composition layer is the core. And the core is made up of mostly iron and nickel. It's this giant part right here, and it's about 1/3 of Earth's mass, okay? Something to understand. These are the layers you probably learned in elementary school. They are the basic layers, okay? Now we're going to talk about the physical layers, which are a little more in depth. All right, so Earth's physical layers. They are divided by physical properties, such as solid and liquid, also including things like how waves move through them, etc. These are going to be more detailed, and there are 5 of them, okay? So the first one is the lithosphere. The lithosphere is this layer right here. It appears kind of a brownish color. And when you look at it, it's technically a rigid layer that's part of the tectonic plate. It's actually the layer that has the plates completely divided up on them, okay? Within this, it's going to contain the bottom of the crust and the very top of the mantle. So that's what this brown part is, the bottom of the crust and the very top of the mantle. The second layer is the asthenosphere, which is this giant red layer here. I know it's a little hard to see the red. In the asthenosphere, you have slowly flowing rock. And this slowly flowing rock is what's basically allowing those convection currents to move. This is moving what's on top of this layer. So the asthenosphere is driving the motion of the plates. So the asthenosphere's motion is what causes the lithosphere to actually move. That's the layer with the plates. Remember that. All right. The third layer is the mesosphere. And meso means middle, if you did not know that. This is the very middle layer because it's layer 3. Not a whole lot specifically that you have to know about the mesosphere. It's just that the rock is going to flow kind of smoothly here, but it's going to flow slowly, okay? So it flows slowly. All right, layer 4 is the outer core. Super important. This layer is liquid, and this liquid is what surrounds the inner core. I often tell students to think of the outer core like a moat. Okay, so it equals a moat. A moat is what surrounds and goes around this castle you might find, and it's the liquid layer. And this liquid layer is going to be the outer core. The castle itself is going to be the inner core. Okay? The inner core is solid and very dense, and it's about 6,380 kilometers beneath our surface of the crust. All right, so this is when you put them together. This side makes up the composition layers, and this side makes up the physical layers. As you can see, they do cross over one another. So you have your crust up here, divided into oceanic and continental. It's not labeled, but there it is. All right, then you have your lithosphere, which is the bottom of the crust and the very top of the mantle. Then you have your asthenosphere. Now notice it breaks up the mantle over here. All of this is mantle. Now look, the asthenosphere and the mesosphere break that up. Mesosphere makes up a majority of it. Then you have your core, and it gets divided as the outer and inner, remembering that the outer is made up of liquid. All right, so we are going to move into relative dating. Relative dating is a great way to help us identify when the layers got there in terms of idea of what's the oldest. Oldest versus newest. It's not going to give us exact dates, but it does tell us what is older than something around it. All right, so what is relative dating? Well, it's comparing the age of a rock layer to the layers around it. It does not give an exact number. So it will not say this rock is from da-da-da. No, it's going to tell you this rock is older than that rock. Kind of an example, if you are a middle child, you might say, I'm younger than my brother, but older than my sister. The rock in the middle is younger than this rock, but older than that rock. That's what we're talking about here. All right, so younger rocks are going to lie above older rocks in undisturbed layers. So this is an undisturbed layer. It's just a normal layer, flat line, okay? Oldest rock's at the bottom, youngest rock is at the top. Think of it like when you're making a lasagna or you're making a cake. The bottom piece has to be put there first, so it will be the oldest. The top piece will be the youngest because it gets put there last. All right, so let's see what can disturb rock layers. There are four major things. Faults are breaks in the earth crust. Intrusions are molten rock that squeeze into existing rock and cool. These will be igneous in nature. All right, we have folding, which are rock layers that bend and buckle. And we have tilting, which is an internal force in the earth that slants the rock layer. Okay? So what can disturb rock layers? And here's what they might look like. All right, so let's look at the four things. These are examples from the book. A fault. This is going to be, let me highlight in a different color so you can see it a little bit better. We'll use yellow. This right here is the fault. You can see it represents this picture, and it's that break in the crust where it's sliding in position. So the line that I circled is the actual fault. Okay, this is an intrusion. You can kind of see it here. This is the book example that shows how something moves into another. Folding is literally what it looks like. It looks like a fold has occurred. You can clearly see it right through here where it creates these almost zigzag shapes that are very like circular in the ends instead of rigid. And then tilting. You can see how it once went this way, but it was straight up and down, and then it did tilt to be sideways, and that's very visible right here. All right, so an unconformity is a missing layer of rock due to erosion. So basically, sedimentary rocks form in horizontal layers, like Exhibit 1, okay? Then the rock layers are going to get tilted. This is going to happen due to folding, and that's that arch shape. And we'll talk about that in a minute. This is an anticline. It's like an arch, and this is the syncline. That's not. The surface then gets eroded, and then eventually the unconformity is going to happen here when the new item is deposited on top, filling in the gap from number 3. Okay? All right, so let's try a rock puzzle. The law of superposition states oldest is at the bottom, youngest is at the top. So what came first? Let's see if you can figure it out. Well, let's go with what we know for sure. Which layer had to be there first? So the first layer that was there we think might be red. Okay, then what had to come? Maybe orange? All right, I'm going to give you a second to look. All right, so let's see how you did in comparison. The first layer was red, the second layer was orange, the third layer was green, the fourth layer was this intrusion. And let me make sure I tell you why. Yellow intrudes rather into the last layer. So at the time, this was the last layer, therefore yellow went all the way into it. Okay, so then we have blue, which kind of appears to be like a blue-green color. Then we have brown, and then last we have the purple intrusion because this became the last layer, and so purple went all the way through it. Okay, let's try one more. Again, note your intrusions. You have a white intrusion, a purple intrusion, and a yellow intrusion. All right, so our oldest is still going to be red, followed by orange, but then we have that yellow intrusion coming in. Because remember, when the last one's there, that tells us our intrusion has to happen. So clearly yellow happened when orange was the last one. All right, then we had green, then we had our blue or blue-green. Then when it was the last one, we had purple, then we had black, and then last was our white intrusion because it intruded into the very last color in the chart.